We have another percent change question here. In these kinds of problems, I like to draw a picture to just represent the situation, just to organize the information. And especially with word problems, it's a good idea to just start writing stuff down. Just get your thinking on paper rather than trying to sort it all out in your head. So the number of crane flies in a wildlife sanctuary is 30% less than the number of ladybugs in the sanctuary. So I'm going to write my ladybugs here. And we know that if I have crane flies, which are 30% less than the ladybugs, that means if I take 30% off of the ladybugs, if I decrease the number of ladybugs by 30%, that should give me the number of crane flies. Okay. Now the number of honeybees is 85% greater than the number of crane flies. So therefore, again, if I take my crane flies and I increase that by 85%, that should give me the number of honeybees. So again, just kind of drawing a picture to organize this information. The number of honeybees in the sanctuary is how many times the number of ladybugs. So here's what I would recommend. A lot of options here. We could start with X and apply the percent changes. That's actually not too bad. I'll show you that in a minute. But let's actually use numbers to make this concrete. And it's okay if when we're making these calculations, we get weird decimals. At the end of the day, we just want to ultimately compare the ladybugs to the honeybees and see how many times greater the honeybees are than the ladybugs. So let's start with 100 ladybugs. You could use anything, but I like starting with 100. Usually makes the math a little bit easier. So it's 100, and then we're going to reduce that by 30% to get the crane flies, which will be 70. Now we're going to take the number of crane flies and we're going to increase it by 85%, and that's the same as multiplying by 1 plus 0.85, right? That's our percent change trick. Multiply your original value by 1 plus the percent as a decimal. And we actually did this back here. I just did it sort of quickly, going from 100 to 70. But here, we were multiplying by 1 minus 30% as a decimal, or multiply by 0.7. Over here, we're going to multiply by 1.85, and that should give us our 85% increase. So I get 129.5. So now, we want to compare this result to this result. How many times is 129.5 compared to 100? So one option would be you could maybe just see that it looks like 1.295, but if you're not sure about that, you could say, well, look, 100 times some multiplier, I'll call it m, is got to equal 129.5, right? And I'm looking for that multiplier, right? How many times the ladybugs is the honeybees? So we can set up this little quick equation. Either way, we'll get 129.5 over 100. And we go ahead and just put that in our calculator. And we get 1.295. So m would be 1.295. So this would be the answer. This is the number, or the how many times greater the honeybees are compared to the ladybugs in the sanctuary. Now, if you wanted to use variables instead, we could do that. We could start with x for the number of ladybugs, and then we want to take our x and decrease it by 30% because that will get us the crane flies. And so to do that, again, like we did when we had numbers, we're going to multiply this by 1 minus 30% as a decimal because we are taking away 30%. So following our percent change trick, we're going to multiply it by this. And then whatever that result is, we're going to increase it by 85%, which is the same as multiplying it by 1.85. So I'm going to write this down here. So it's x times 0.7 times 1.85. And really all I'm going to care about is this product here. That's the beauty of multiplication. It's commutative. And so I can just do the 0.7 times 1.85 first. And look what we get. We get 1.295x, which is literally what we had above when we were determining the multiplier. So we can see here, whatever the number of ladybugs is, we multiply it by 1.295. And that gets us the honeybees. So either way, we should get 1.295 as the answer.